I think the last we left off with this project with the Stream Deck here, we had printed out a test part we had started printing out the test part to see if everything would fit. And this is what we ended up with, which not the prettiest thing in the world here, but that's not what we were going for. We were just trying to see if...
That's what prototypes are for.
Yeah, exactly. Just trying to make sure things fit. And it's a good thing we did. Let me grab some keycaps here because this isn't right. It's a little off in a couple of the directions here. So if I punch these in here, we'll start to see in a second. I think here. I mean, they fit. Oh, geez, I can't get my fingers to work. Sorry, hold on. They fit in here, but the problem is that it's a little too tight. So I believe you can start to see it. Actually, probably not, because the wide angle on this camera is actually distorting it back to normal. But yeah, you can see it.
Right?
Yeah, so by the time you get all of them in here, it's like really bending. So I went ahead and changed a couple things and reprinted. And, geez, things are really in there. Put these back in here.
At least you know they won't fall out.
Yeah, they definitely won't fall out. But even in the new one, they're pretty tight. So here we go. And here's the finished one. Well, at least more finished. With the... I added the screw holes through in the model. I'll show that in a little while. I added all the keycaps. And this one, it does... slightly bend over time, but that's after sitting in here. I've probably had these in here for about a day or so, but it's not anything extreme. It would definitely...
Yeah, but if you build the rest of the structure and put the... actually mount it to something, it'll hold its shape better.
It's definitely enough that, you know, yeah, screwing this in will help. And these screw holes are countersunk so that we can... get some stuff off my desk here so I can grab it.
Are we using a standard size, like M620 or something like that?
I'll be honest, I don't know what these are because these I happen to have in my little toolbox here. So I just measured these and got it to fit so that they're countersunk in there and that they're just regular sheet metal screws that will grab the plastic. And I've got the standoff in the bottom case that is kind of modeled out during the last one, but not fully with the mounts for the Arduino and all that. So we'll get to that eventually. But yeah, I believe you could use that looks to be probably about an M3 or M4 screw. So we could use those. I do have some of those, but I happen to have these, so I'm just going to use these. But we could, the model could be adjusted to use those as well. These tend to grab a little better.
If we put this out there, for people are going to be like, hey, you know, these are the exact parts you need.
Exactly.
You know, go find something random.
And well, that's one of the good things and the bad things. So like, you know, definitely when we put the model out there, we'll go through and try to make a pick list of like, here's the things you would need to assemble this. And this is just one version of this too. So there's other ones out there that are software projects that we could probably make a revision of this later. Also, where it's just software using an old phone or an Android, you know, just with a web page or something. So I've seen a couple projects out there like that too. But
I think actually
starting with this
brand name one has a mobile version as well you can use instead of buying their...
Yep, I think so now. So, but this is nice because for me at least, this is something that I can use for not just OBS, but because it emulates a keyboard, you could just go ahead and change the code and make this emulate, like you could have a one button enter your password if you wanted, which is kind of cool too. Completely insecure. Yeah, completely insecure until like, you know, someone gets a hold of your keypad and just types your password everywhere. But hey, you know.
Or you hit the button in the wrong window.
Type it to your entire work, or like someone at work did one point and accidentally type it in their Skype status. Yeah, pro tip for security, don't put your password in your Skype status. People might figure out what it is. So, but here's where we are. So this is a good start for today. I'm going to try to tackle some of the software today, and I did run into some problems with this. Now, you'll notice that, you know, I've got the little button here, and if we zoom in on this here, put this down a little closer here, we can see that the pins I've got here are the ground and reset. And the reason for that is the bootloader they use in this has a delay in it. So when you start up normally with the Leonardo, I believe it gives you 8 seconds. You reset it, it gives you 8 seconds to do a bootloader, and then it goes about its normal programming. This one they modified so that the bootloader has 750 milliseconds to run, and if it doesn't get anything, it'll go immediately into your program, just to keep people from getting delays once it's, you know, a built project. So the way around that is you have to quick reset it. So if we plug this in now, I've got a test program that I was using that they provide on their site, and by they I mean Seed Studio. And we can see it's just gonna blink back and forth here. And if I switch over, there it is. Yeah, so there we go. So now we can get to the actual like programming here. So the next hurdle is going to be using it as a keyboard, which I have no idea how to actually do that. I did read, let me see if I can pull this up. Okay. So I was following along with this, and they had some code on how to use the board that has the Atmega 32U4, which is this Pro Micro, which also the Leonardo, a couple other different ones, and it functions as an HID, or human interface device. So the other thing we've got to talk about is how we're going to interface the buttons, because I think what I'm going to try to do is use a matrix. I think we can do that. It's been a while, but let's hop over. I need to have a test button. Let's see how this one's set up on there. Come out the front, right? Yeah, okay. Is this not one? Oh, I'm trying to touch there. Okay. Alright, so we've got that there. If I look at their diagram, they have a simple resistor, so I think they're doing a standard... What are they doing? They're connecting VCC and ground. It looks like they're doing a pull down. Yeah, okay. So you want to do something like this. The pull down resistor is there so you don't have floating inputs. So the thing is, we can do something like this, right? We can go through and we can take, what do we need? We need VCC, so we're taking the output here. Do it here, and we're connecting it to one side of our switch, right? And what that'll do is when I press the button, of course, you know, the 5 volts from the chip will come out this side and this side. But then the problem is, so I can very easily go ahead and do this and connect this to one of the digital pins, and that'll work. The problem with it is that once I let go of this button, this pin input is floating, right? So what can happen with that is that, well, like I always like to say, computers, even the little microprocessor here, are just rocks that we tricked into doing work for us. And believe it or not, even though we use them every day and they're fairly reliable, they can be very finicky. And they don't deal well with analog things, right? So when you have things like this, where, you know, even if I just go ahead and, you know, connect this to a digital pin, I could sit here and touch this and trigger a digital read on that pin. Like if I were in a loop and I'm just going over and over and over again, reading it, just by touching it, I could create enough capacitance, or I could have enough static charge on me or whatever to make that believe or read as a value. So the problem with that is yeah, this will work most of the time, but what we usually like to do is in this case, it looks like we're doing a pull down. And all that means is we're going to take the ground that we actually have here already, to be honest. So what we'll do is, I think I can fit another one in there. So yeah, let me go ahead and pull it here. Pull it direct from ground. And what we'll do is we'll put a resistor here. I don't think we need a big value. Well, you do need something fairly high, because when we click this, we're going to connect this and this side of the switch. And when we do, if you just connect this direct to ground, you're going to have a direct short to ground, which means all your current's going to go through here, and you could, well, you may not right away, but you will eventually wreck that chip. So you want to have a high value resistor so that, or, you know, fairly good size one, so that you don't have a short circuit, but you do have a path to ground. So I don't know what value we have here. I'm just going to arbitrarily pick one. I do not advise doing that, but I'm just prototyping at this point. So I'm going to just go ahead and stick this here. I don't know what a recommended value for one of those are. I should probably look that up. Usually, I want to say like 10K or something like that. Anyway, now if I do that and I click here, I didn't break anything because it's still running, so that's good. But now we don't have any code that's doing anything, so let's...
So we know to go look at what? Is that digital pin 3?
Yeah, that's pin... Yeah, let's change it to be pin 2, to be honest. Yeah, let's do pin 2. So it's digital pin 2. So if we look here in their code, and they're setting things up to actually be a keyboard, and we're not there yet, this is what we want to do. They've gone ahead and they've got their loop set up. You've got your setup and then your loop, whereas we've got the serial print and all that. So what we want to do is we want to just kind of take this code, because we're just going to be debugging some things. We don't need it to say hello world new. I don't need this any longer. But what we'll do is we'll just tell this to
put for now the console output.
We're just going to say, you know, button down. And then the other thing that we're missing from here... Oh, you know, I guess you don't have to do that, huh? You know, I'd gone in length about the pull-up, or the, I guess in that case, that's a pull-down resistor. But some of the boards have internal sinks where you can set in the code, whether it's a pull-up or pull-down. So I'll have to look at that, because you may be able to get away with allowing it to sync its own current. And for simple things like this, where you're reading the button presses, that's okay. When you get into more complicated things, when you're driving relays and stuff like that, you probably don't want to use the pull-up, pull-down, because of the fact that you could sync too much current and blow something out on the Arduino, which you don't want to do. So we could probably get away with not needing that on here if we looked into that, but it's another thing we could look at later. And we'll leave this here just so that we know this thing is still running.
Do you need to upload the new code and then reset it again?
Yeah, I pushed the button.
It
did nothing. Oh, you know what? It's delaying. Yeah, there we go. See, because my code is bad, I should feel bad. See, because I've got those delay statements in there. So it's literally setting the thing, waiting 2 seconds, setting the LED high, waiting 2 seconds, and then reading the button. So I have to hold it down a good bit before it actually gets to the point where it's reading my button press.
Yeah, but it's at least reading the button press, so...
It is, so that's progress.
It's easy enough to go take those delays out now.
Exactly, progress is progress. So I guess the next thing is to figure out how we're going to go ahead and read these buttons. Because we don't have one button, we've got 16 of them, right? 1, 2, no, yeah, I can count 16, 4x4. So we got 16 key switches, and for those yelling at me from the last video, I kept saying key caps. You're absolutely right, they are not key caps, those are key switches. Key caps are something we're going to have to do in the future, which I'm going to have to look some up. I guess we can maybe design some and resin print some, yeah, or even try... I don't know how they'd come out with FDM. Resin would probably work a little better. But we can try both and see, compare them and see if it's possible, or what settings we need to do for that. So, let me switch over here. Okay. So the problem we have is the fact that we do have a lot of inputs on this chip. But we definitely don't have Actually, we kind of do have 16, but we definitely don't want to use all 16 pins, because we may want to do other things with this. We may want to have a display or something in the future. You know, maybe a button to shock people that press the wrong button. You know, you never know. You gotta have options, right?
Button.
Yeah, exactly. The end of the world. In a normal keyboard, you've got to worry about pressing multiple keys at once and being able to read all of them. And we're probably not in a scenario where we really care about pressing more than one key at once. I mean, we're probably just going to use one key.
Yeah, just one key
at a time. Right, so what we can do is, as I get my pen, and you guys are going to be gifted with my tremendous drawing skills here. And hopefully I've got a pen that actually works. So imagine these are our switches here, right? Oh, you can't even see that well, can you? Here, let me...
That's very rough, but...
There we go. That's a little better. So, what you do normally is you have 4 lines that go this way and 4 lines that go this way, right? And then you can read 16 with only 8 pins. And of course, how do you do that? In the code, we would set, you know, if this is pin 1, 2, 3, and 4, because the pins on here are bi-directional, you can either use them as outputs or inputs. So what we'll do is we'll take 4 pins and use them as outputs, and 4 pins and use them as inputs. So we'll call these A, B, C, and D. And the reason is just to segment that these are out and these are in. And what we would do is we would send a signal out. So we'll set one high, and then we'll go through and read A, B, C, and D. And we'll see if there's any values. And if there's 0, we know no keys here were pressed. I have to look at it because you should be able to read them as a bit register and be able to just say, like, look at the 4 bits and see, is this set in binary and all that. So you could do digital write pin 1, digital write pin 2, digital write. In fact, for the writes, we'll probably do that because we're not going to be sending out multiple at one time. But we want to read all these as quickly as possible. So we should be able to do a digital read against the register, or however these are set up, and be able to pull the values back and kind of break it apart bitwise. But for now, for simplicity's sake, when we write the code, we can just do digital read of A, B, C, and D. So anyway, we just cycle through and we send, you know, bits on 1, 2, 3, 4. We read A, B, C, D, however we do it, as one bulk read or whatever, and we'll be able to tell which one of these buttons are pressed. And then we just need to go ahead and handle the key press, whatever we're going to do. So I think that'll work in theory. We'll use these. I've got these as a test. Okay, so we'll disconnect this, because you should never hook things up while
the
got
power
things
runs through it.
Power, yeah. Generally not a good idea. Although I think I did it before, but yeah. So what we've got here is basically this. Right, where we're going through. We're not saving any pins with this because we got 4 buttons and 4 wires, but you know, having the next one would save us, because we'd end up with 9 buttons and 6 wires. So that's where you'd start having savings for pins. But anyway, what we've got is we've got pin 2 is connected to this switch and this switch. That's what this wires here is doing. And then pin 3 is connected to this switch and this switch. So when we pulse pin 2, we'll be able to read a value from whether this button or this button is pressed by looking at the return value for a 0 or a 1. Okay. So that looks correct, except we need to do a pull down for all of these. So what I am going to do is this. I'm going to go ahead and push ground into the ground plane here. Do we have a shorter black wire? Yeah, there we go. Okay. Black. Ground. Put that there. Actually, you know what? Probably better if I do this and put the ground here. So there we go. And then go ahead and connect this here. And then connect this here. Okay, so we'll have a diagram here to make this make a little more sense, and we'll see the final one too. So let's go ahead and switch over. Guess we can plug this back in now at this point. Let that do its thing. So let's go here and let's move this out of the way. And I'm looking for the pinout diagram. Actually, it is 18.
Oh.
18 and 19.
The one I'm looking at lights me.
I could be looking at the wrong one. You know what? I am looking at the wrong one. I'm looking at the Flow V3. A0... Nope, they're still 18 and 19. I am looking at this hookup guide. If you look at the top, you'll see the Pro Micro and you'll see the blue pin numbers. I guess it's analog A0 and A1? Oh, that's what the A0, A1 is. Duh. Okay. Mm-hmm. So we want to read 18 and 19. Button down A0. Oh, I see. Got it. Oh, well...
That code example.
Well, that's actually a matrix keypad, isn't it?
Yeah, but it's
nice.
A 3x4 instead of...
Yeah, okay. And so A1 is 19, right?
Yes.
And I don't know where that equal came from. So let's remove that. And this is horrible code. You should probably never write code this way, but it's also just test code. So the other thing is we're not setting these high. So what we need to do... What do we need to do? So we need to do this a couple times. So we'll write a function for this because I'm getting itchy even thinking about the way I'm going to write this. Because you know what's coming. We're going to write digital write. How do you write out a pin? So it's digital write, correct?
Yeah, I believe so.
And then you
it should
tell
be
it...
digital write in just the pin, I think.
Okay, but do you have to give it...
high.
Yeah, you have to tell it high. Okay. Nice, okay. Oh, we have to tell... Do we have to set pin mode?
Yes.
Okay, so let's write some bad code. Ah, here we go. We've got it up here, actually. Pin mode. There we go. So we want pins... We want pins...
2 and 3?
Yeah, I think. Or 3. We want 2 and 3. Now we should be doing like they have here and have constants. Right
well,
now.
ideally when we have the matrix, we can probably just run a loop for the pin set.
Yeah, exactly. Just have an array and go through it. We're kind of just hacking it real quick to see if it works. So we're going to say digital write to high. One of the other things we're going to do in here is, in addition to setting the pin mode, we probably also want to set everything low.
Do we want those to be output still?
Yes. Right? Because pin modes 2 and 3 are feeding these up at the top.
Okay.
Right? I believe so, right? That makes sense.
Yeah.
Okay, so pin mode 2 is out, 3 is out. I guess for good measure, we should set the others as input, right?
19 input, yeah.
Yeah, so that was 18 and 19. You know what? I'm gonna go ahead and... No, I'm not. We'll just go ahead and do this. 18. It's killing me, man. Everything is telling me, no, don't do this.
I guess I've worked around amateurs more often, so that I'm just like not phased by it. Like, yeah, just clean it up later. I'm not gonna.
You guys can't see me because I don't have a camera on, but I'm literally twitching. Like, my left eye is, like, twitching a bit. It's getting hard to see the screen. But, you know, when you're first learning things and you're hacking things together, this is how you do it, you know? And you just try to figure out what works. You copy-paste things until it works. You know, and you just go back and you refactor things and you make it clean and reusable. So we've got that.
You just leave it as is.
No, we don't do that. No, do not listen to that part. You do go back and you clean it. Or else people will attack you. Yes, so, and I know we did that here. In fact, a copy-paste error. So what we're going to do is this. We're going to tell this hi. We're going to use all caps because it's a constant. And 3 low. Okay. And we're going to read those. And then we're going to do it again. And we're going to go low.
It'll switch them. Yeah.
And high. And actually, we probably want to have a bit of delay in here for a rebound, for, what do you call it? To give it time to, like, settle. It doesn't have to be much. It could probably be just 50 milliseconds. I'll just do that and give things time to settle. And then we'll read button down A0, A1. Okay, so let's look at our diagram and let's look at our buttons set up here real quick. If we go over and look at this, so we've got things here. So let's walk through our code and talk through it while we're looking at things. So we've got pin 2 and pin 3. So we're gonna set pin 2 high and pin 3 low. So now this pin here and this pin here will be high. So now if I press this button, I will send a signal to A1, I believe, right? Let me double check here. No, I have them backwards. Wait, which one's... Yes, that is correct. So if I press this button, I'm going to set a signal, a high value or a 5-volt value to pin A0. If I press this button here now, I'm going to be setting a... No, I'm not, actually. I have this wired wrong, don't we? We have this wired wrong. This is why you talk through things. So this actually needs to go here. Right? So this needs to go here. Yeah, that's what it needs to do. Because this is going to be A0 and this is going to be A1. Right?
Okay, then your red wire needs to move somewhere. Yeah.
Yeah, the red wire needs to move as well. So this is, yeah, that's the problem there. So that needs to go over to, if we're keeping it consistent, that needs to go and read from here. And same thing here. This needs to loop back to this original one. Right. And I'm also doing what I said never to do. So do as we say and not as we do in that regard. And we'll put the pull up on both of these over here since we have more room. It makes more sense. Okay, that looks better because now this pin 5-volt will energize these two switches, which is basically, you know, this rail here. I use my pen here because it's more of a point. And now I need to differentiate between these two buttons because these buttons are going to be active. So I need two inputs to be able to read these. So I'm going to have, let's see if I say the right one, A0, A1. Same thing over here. When we turn this pin on and this pin off, now when I press this button, I'll be energizing A0, right? Yeah. And this one will be going to A1. That's the theory. So now that we've got that, we talked through that. Let's switch back here. Now that we know that, so if pin 2 is high and we've pressed 18 is A0, so we know that A0, we know we've pressed button 1. If we pressed A1, we know we've pressed button 2. Now, down here, we know that A0 would be button 3, and A1 would be button 4. So, In theory now, we should be able to flash this. And it's loading. And let's clear this. And let's prepare to be disappointed. Because code never works the first time. Yeah, see? We got something going on there.
So you're pushing both 3 and 4 at the same time.
Yeah.
But we're at least in the right set, right?
Yeah.
So...
Okay, so what do we got going wrong? I know what we got going wrong. I know what we got going wrong. So the problem is when I press the button here, like I said before, when you're shorting things out, when I press the button here, I'm shorting the path between these out. So electricity is flowing through to both of these, right?
Mm-hmm.
Yeah, so that's the problem right there. Hold on. Let me work through this. Oh, it's because of these. Isn't it? These are connecting both together.
Yeah, because yeah.
The problem is our resistor's in the wrong spot. We need to have the resistor here. And I need to get another one. That was the problem. We had too easy of a path to ground. This is why you prototype things. But the other thing that'll make it easier is if we just look in the code and see about the actual pull down. Because we shouldn't have to worry about that. And then we'll go through here. And again, don't do this. I'd say I'm a trained professional, but we all know that's not true. I learned how to do this just by playing around with things and breaking things. We're hoping to put this together so that you don't have to break the things. Do not break all the things. Things are expensive. Okay, so cleared this out and I fixed that hopefully, so now when I press, see, there we go. Now it's actually 1, 2, 3, and 4. So there we go. So there is what we need to do for our matrix. So let's look up the data sheet here for Arduino pull down. Internal pull down resistor. Yeah, see, here you go, right here, direct from Arduino's information here. A 10K resistor is a good value for a pull up or pull down resistor. So that's all you need is a 10K resistor. There are 20K pull-up resistors built into the Atmega chip that can be accessed from software. These pull-up resistors are accessed by setting the pin mode as input pull-up. This effectively inverts the behavior of the input mode, where high means the sensor is off and low means the sensor is on. The value of this pull-up, and most AVR boards, the value is guaranteed to be between 20 and 50K. For the exact value, consult the datasheet of the microcontroller on your board, so we'd have to go look that up. Pull-up resistors provide enough current to dimly light an LED connected to a pin that has been configured as an input. Unfortunately, though, that's not what we want, because we don't want a pull up, we want a pull down. So, what we're going to have to do in our circuit then, which we didn't really plan on, but I guess we'll have to make the changes, that each one of these lines in our diagram, each one of these is going to have an individual resistor to ground. So normally we would, write that as, this. All these lines sync to ground. And that's essentially what we're doing here. It's just, we're looking at like 1, 2, AB, really. Yeah. So that's what we've got. We've got our code there. So that took a bit longer than we expected, but hey, we're learning this too. So that wraps it up for this video though. In the next one, we'll start looking at cleaning up our code. It's a bit of a prototype right now, so we'll definitely want to tidy it up a bit. And then we'll want to add support for all 4 lines. We'll also want to maybe start looking at modeling the base and getting that together, along with getting it to send some key presses back to the computer. So that's it for now. See you in the next one.